Okay, ladies and gentlemen, I hope everybody has logged into their code.org Unit 3, Lesson 18. This is our lesson on velocity. And again, I just want to remind you that all of these things that we're doing in Unit 3 are building to our final project, which again, once again, is going to be a simple video game scroller style. Okay, so it says velocity X. So we're looking at velocity. One way to move sprites in GameLab is with a counter pattern. So sprite.x equals sprite.x plus 1. This is the counter pattern we have been using. This pattern is so common that the sprites have a velocity X property that does this for you. Then it says, do this. Let me make sure that this is the right. Oh, let me start over. I knew I had forgotten one. Like it looked on. Come on. Do this. Drag a sprite dot velocity X block directly below where your sprite is created. So, and if you want to know where, it says show me where, and it'll be like right here after I create my sprite. Remember, so we create the variable, we set the animation. Write the name of your sprite in the block. Assign the X velocity X a property of 1. Run the code. What happens? Rerun the code with a different value. What is changing? All right, so let's see what happens. So if I run the program now, I have a fish that just kind of hangs out because he's a fish. Now it is set an animation. So now it's saying add a velocity X. Give it a value of
Submarine.
I'm sorry?
Nothing.
Okay.
No, I was saying it was a submarine. It looked like a submarine.
Oh, okay. All right, so we are going to bring velocity X in. Now remember, velocity X really is that counter pattern, but they've already coded it for us. It's just trying to make things a little bit easier for us. Oh, I already pulled one in. My bad. I did it twice. Okay. So the first thing we need to do is to change the name of the sprite to fish because that is the name of our sprite. And then it said to set it to a value of 1. So I'm going to go ahead and reset this, and I'm going to run the program. And now we see that without using the draw loop, it is automatically moving, which is kind of nice. It has just become a property of the, what's it called, of the sprite itself. And then it says try it at a higher number. So I'm going to try a value of 5. Now you can use whatever number you want, as long as it's higher than 1. And I'm going to run it, and we can see that it is running faster. So again, this sprite velocity X, sprite velocity Y are going to be that counter pattern that we learned before, but with just one line of code. So it is going to help simplify our code for us because again, as we get into these games, it is going to get really complicated really fast. So we need to have these shortcuts for our code.
Miss Cano, I have a question actually.
Yeah, go ahead.
With velocity, right?
Mm-hmm.
Couldn't you add that to words? You can add that to words, right? Or is it on?
You can add this to anything that you have created as a sprite.
So I could so say I was creating a web page, right? Right, and it had a moving text, right?
Mm-hmm.
That just went across to the bottom. You could technically add velocity. Oh, okay.
Absolutely.
Oh, okay.
All right. Any other issues or questions? Okie doke. We'll go ahead and hit finish and continue. All right, so now we have our buddy, and we are going to go ahead and check out the video where he is going to further explain the velocity code to us for GameLab.
South Carolina, and now I'm all the way over in California in Silicon Valley. And here, software is all about optimism. It's not just a means to an end, it's this thing that gives us hope to solve every problem that the world potentially has. Moving your sprites around the screen means using a very familiar pattern, the counter pattern. This pattern lets you add to the position or rotation of your sprite on each tick of the draw loop, so it looks like it's moving or rotating at different speeds. Here's an example we've seen before. Using the counter pattern with the sprite's x property, we can control a sprite's velocity, how fast it's moving in a particular direction. If we add a larger amount to the x position, the sprite looks like it's moving faster. Adding a smaller amount makes the sprite look like it's moving more slowly. You've been using the counter pattern to control a sprite's velocity a lot. In programming, when the same pattern happens many times, you can often hide those details inside another block. In our example, that block is velocity x. The velocity x property hides the details of the counter pattern that changes the sprite's x position. Whatever number you assign to this property will automatically be added to your sprite's x position on the next tick of the draw loop. This program creates a sprite, gives it an animation, and then draws it on the screen. Now let's give that sprite a velocity by setting its velocity x property to 1, just once, at the beginning of the program. When we rerun the program, we see that the sprite's position is updated. Under the hood, the velocity x property and the counter pattern are used to update the sprite's position, moving it across the screen. The other new properties that work in a similar way are velocity y, which controls velocity in the vertical direction, and rotation speed, which controls how fast the sprite rotates. The under-the-hood behaviors of velocity x, velocity y, and rotation speed are all things you've tackled in previous lessons. Now, we get to let those blocks handle the details for us and explore new ways of moving sprites on the screen.
All right, so that was an explanation of how to move sprites across the screen with slightly simplified code. Please remember that that new block of code really is the counter pattern that you already know. It's just a simplified version of it. So it's all still there, it's just under the hoods, as the guy kind of said. All right, going back. So now that we've seen the video, we can go ahead and hit continue. And again, you guys can come back and revisit these videos as often as you need to in your code account. Okay, bubble number 3. All right, let's go ahead and run it. All right, so it says, here is a feather sprite that should be floating down the screen. If velocity x makes a sprite move to the right, can you find the block that will make the feather move down? Find the block that will make the sprite go down the screen and use it outside of the draw loop. So looking at these choices that we have, ladies and gentlemen, if x makes it moves across the screen, which one would make it move down the screen?
Y. The Y.
The Y. Awesome. Okay, cool. Let's go ahead and put that in. I'm going to assign it a number of, let's say, 2. And let's go ahead and run this. Okay, I'm getting an error. Why am I getting an error? What did I do wrong?
You ain't put a number in.
I did put a number in. I put a 2 in.
Oh, I ain't get no error. I just completed it too.
I'm sure you did, and you probably did it right. I did it wrong on purpose.
The sprite.
Oh, the sprite. The sprite.
There it is. Yep, we got to rename the sprite, guys. I don't have a sprite named Sprite. I have a sprite named Feather. Good catch,
I thought I was
guys.
tripping for a second.
No, you're just better at this than I am. Look at that. See? There it is, going down and down and down. Perfect. Okay. So again, if we want something to go down the screen, we are going to use velocity y. Awesome sauce. And I'm going to go ahead and hit continue. Okay, this one says you can use rotation speed to make your sprites spin. If you want your sun to rotate by 2 degrees each time it's drawn, you can use sun dot rotation speed equals 2 before the draw loop after you create your sprite. Do this. Make the sun rotate by 3 degrees every time you use the rotation speed block. Okay, so I know what I'm doing. I'm going to make this a little bit bigger, and we are going to run it. And right now, I just have a sun. Okay, so now we have this rotation speed. Again, this is the same as that counter pattern that we had to use, like sprite dot rotation equals sprite dot rotation plus that big line of code that we used to have to do. This is being replaced now by this simple one-liner. All right, so we are going to do sun, change the name of the variable first, and then it said to increase by 3 degrees. Sun. And then we're going to increase this by 3 degrees with each tick of the draw loop. And we are going to go ahead and reset and run it. And there she is. She's moving. Now, as always, if I wanted to spin faster, I would just pick a bigger number. So I'm going to pick 10. It's really kind of chugging around there now. Okay? So again, same as X, which moves it across the screen. And then Y moves it up and or down the screen. Rotation makes things spin. And again, notice this is going outside of our draw loop because this now has become a property of our sprite. So every time we draw the sprite, this is already going to be incorporated. Again, it's going to help simplify our code in our games that we'll be making eventually in this unit. Issues or questions? All right, continue. Oh, there we go. Computer's running slow today. All right, controlling speed. You use rotation speed outside of the draw loop to make your sprite rotate when your program started. You can also use rotation speed inside of the draw loop to change the speed during the game. For example, a sprite can't start rotating when a user presses the spacebar, but it will keep rotating until it's told to stop. Do this. Look at the if statement inside of the draw loop that checks whether or not the spacebar has been pressed. So that's right here. If key went down space. Use the rotation speed block to make the color wheel start spinning when the user presses the spacebar. All right, so when I run and I'm pressing my spacebar, nothing's happening. Okay. So I'm going to use a conditional statement. So I already have my Boolean. If key went down space, okay, rotation speed. Let's go with 5. I don't really know why. And then the name of my sprite is now wheel. So I need to make sure I change that. So I'm going to go ahead and run. It's still not working, right? So it's still not spinning. But if I press down my space button, it now works. And it continues to spin because this is just checking, did the space button ever go down? Yep, I pressed it and it starts moving. If I press it again, it's going to keep moving and moving and moving. Okay? Issues or questions? So again, you will be, go ahead.
I kind
One more time. One more time.
I kind of messed where you got this. Well, mostly it's just more I can hear you guys.
Your mic is messing up.
It might be easier if you put your issue or question in the chat. I have a lot of static coming through your mic right now.
Miss Carol.
Yeah, go ahead.
Okay, so I couldn't really hear you mostly because there's like people cutting my grass right now outside, so it was a little bit loud.
Okay, no problem. We'll do it again. All right, so just needed to reset itself. All right, so this one is asking us to, inside this conditional statement that we already learned how to do, to make it so that my wheel spins if I press down my key, my space bar key. So in order to do that, what we are going to do is we are going to say if the space key goes down, then I'm going to have rotation speed. And in this case, it's going to be for the wheel. That is the name of my sprite. And like I said, I'm just going to give it a speed of 5 because why not? When I run this, nothing happens originally, but the minute I press my space bar, it starts to spin. Now, I can't get it to stop because I did not give it any sort of direction on how to stop yet. But what I do want you to notice is that if you want it to be user controlled, it will still be inside of a conditional statement inside of the draw loop.
Oh, I see. Is that like a future lesson where we're learning how to, do all this complicated stuff like, stopping it, all that stuff?
Yes, because that's what we're building towards when we work on our game.
Yeah.
Yep. Okay. Any other issues or questions? Okie doke. Go ahead and hit finish and continue. We are now working in bubble 6 of lesson 18. It says changing velocity with position. One advantage to using the velocity box inside conditional or if blocks is that your sprite keeps moving even after the condition stops being true. For example, you only had to press the key once to start the color wheel spinning, and it kept spinning forever. This code below uses if statements to make the fish sprite move in different directions. Do this. Look at the if statement that checks the sprite's position and set its velocity. So that's down here. Okay. Discuss what you think the code will do and write your answer below. Once you have submitted an answer, run the code. So again, this is like a hypothesis. You are going to look at this code and you are going to try to make a prediction as to what you think is going to happen. All right, so let's see what we have. We have velocity of 2 on the fish. If fish x is greater than 0, then my fish R animation will be set. The fish velocity will be positive 2. If fish.x is greater than 400, then my fish animation gets set to fish L, and my fish velocity becomes negative 2. So, any ideas at all on what do you think is going to happen when we
The
run this?
fish gonna move fast.
The fish may move fast. Anybody else?
The fish is going to, move pretty slow, normal speed.
Okay. All right, so let's see what happens. So it says if the fish is less than 0, then my velocity is 2. If the fish x is greater than 400, then my velocity is negative 2. So when I run this, there's my little fishy. Boop. Oh, he turned around. What? Boop. All right, I want you to notice this. Here is the Boolean expression that's causing this to happen. It's saying if the fish's x position is less than 0, because remember, our grid is from 0 to 400. So if it gets to be less than 0, then my velocity is positive 2. In other words, it's going to make it go this way. However, if my fish position is greater than 400, remember, that's the end of my thing, then my velocity is negative 2. Because again, negative moves it in this direction. And I'm even changing my animation so it actually looks like my fish turned around, which is freaking awesome. It's not just a fish swimming backwards, it literally looks like he flipped around. Okay? But again, what you need to do for number 6 is to just make a prediction as to what you thought would happen prior to running the code. Issues or questions? By the way, this is a very simple way of keeping your, I guess, quote, player or your character for a game on the screen. All right, last one, and then you guys will have time to work. Okay, this ball bounces back when it hits the bottom of the screen. Can you make it bounce back when it hits the top of the screen? Do this. Run the code, see how it works. Look at how conditionals and velocity are used to make the ball bounce at the bottom of the screen. Add code to make the ball bounce at the top of the screen. All right, I'm going to go ahead and put on my grid. And we are going to play. Boing. But then it doesn't come back. Okay, let's try it again. It comes down, it hits the bottom of the screen, and then it goes back. Okay, so what I want to do is I want to create a secondary conditional to make sure that it doesn't go just forever off the screen. Now remember, for some reason, in code.org, the top of my grid is y equals 0. The bottom of my grid is y equals 400. So I am going to go into control. I'm going to grab an if statement. I need to create my Boolean expression. So as this one was if the y is greater than 380. So I'm going to say if the y is less than. So I'm going to pull in the less than operator. I want the y position less than, let's say 10, because that's kind of the top of the screen for the y. Change the name of the sprite to ball. Then what do I want to have happen? I want my sprite's velocity. If it was -5, I want the opposite to happen. So I'm going to go +5. And again, I'm going to change my sprite's name to ball. All right, so let's see if it works. So it already hit the bottom, and it bounces up. There you go. So again, if the ball's y position is less than 10, then the ball's velocity becomes +5. Because remember, positive for y is in the down direction. Again, I know it's weird, but that's just how this particular program is set up. Negative for y is going up, which I know is counterintuitive. It's backwards from what we see in math class. Are there any issues or questions?
Yeah, my dog was barking the entire time you was saying that. Can you just go back? Just,
Yep.
yeah, thank you.
No worries. Okay, so the idea is we want this ball. We run the program. It comes down, it hits the bottom, bounces, and then heads towards the top. But then it just kind of keeps going. We want the ball to stay on the quote, the soccer field, right? So we need to create a conditional that will bounce it off the top of the screen and bring it back. That being said, this is the code that makes it bounce off the bottom. If the y is greater than 380, then the ball's velocity will be -5. I need to create a second conditional for the top of the screen. So that's exactly what I'm going to do. So if that's less than, then my choice is going to be greater than, because again, it's going to be sort of the opposite. At the bottom of the screen, the opposite is going to be the top of the screen. So if the ball.y is less than 10, then my sprite's y velocity is going to be not -5, but +5. Again, I'm just creating the opposite. Oh, and I need to change the name of my sprite to ball. Now when I run this, and again, I want to turn the grid on, and I'm sort of following it. When it just keeps kind of going back and forth because it has the two conditionals. It's saying if the ball's y becomes greater than 380, make the velocity -5. If the ball's y is less than 10, give it a positive velocity. Again, these are within conditionals inside of the draw loop. Issues or questions? Okay.
No.
All right, ladies and gentlemen, so this is your time to work. You have two practice ones, A and B on bubble 8, and then on bubble number 9. You are being asked to using right arrow, right hand side of the screen, left hand. So basically, we want the fish to stay on the screen. Okay, so make sure you read the directions there. And again, there are a couple of different animations, left and right facing fish, that you'll have to change. This is very much like the one that we saw earlier, ladies and gentlemen. All right, so you have the remainder of the time to get your work done. As always, if you have issues or questions, please ask.